Hello, excuse me. Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we're about to solve is the one that you will find on page number 290. Today is our lesson number 224. Problem number 161 is what we're about to solve. Let's take a look at it. The very first problem in the second column. It says the inflation index for 1989 relative to the year 1970 was 3.56. One more time. The inflation index for year 1989 relative to 1970, that's the key part. Relative to 1970 means 1970 is being used as the base year. 1970 is being used as a point of reference. And the point of reference, whenever we are building an index, is always used as 100. That's our point of reference. Then they go on to tell us that in the inflation index for 1989 relative to 1970 was 3.56. 3.56 is same as 356. What I just did here is that they are using point of reference as 1, the base is 1, and then they're saying 3.56, but using 1 is annoying. It's much better, it's easier to just deal with point of reference as 100. 100 because it's easier to do the percentages and so forth if you have to. So since I converted this 1 into a 100, I multiplied by 100, 3.56 becomes 356. You see, you no longer have to deal with decimals. What is the question asking? What was the price of a mixture in 1970? Well, let's see what they tell us. Now before we do any work, in order for us to figure out the price of a mixture in 1970, what we have to realize here is that the price in 1970, the price in 1989 rather, we know now is 3.56 times the price in 1970. So in order for us to figure out the price in 1970, somehow we have to establish the price of the mixture in 1989. That's what we're looking for. Let's see what they tell us. In the first statement they tell us the price was $120.40 more in 1989 than in 1970. There you go, that should do the trick actually. That should do the trick because they're telling us exactly, precisely what the difference was. This is how we can write it. Price in 1989, we are told, was whatever the price was 1970 plus $102.40. But we also know that the price in 1989 is 3.56 times the price in 1970. There you go. There is your equation. And we have to figure out the price in 1970. This is our equation. Using this equation, you can very easily solve for the price in 1970. That's your unknown. That's your x. And therefore the first statement by itself is sufficient. Because we don't actually have to do it out. They're not asking us to actually figure it out. We just have to establish that we do have sufficient data sufficiency. We do have in fact sufficient data because this is a very simple linear equation. We just have to solve for it. It can be done. AD BCE. Because we established just now that the first statement is sufficient for us to be able to answer the question that is being asked, the question being what was the price in 1970, it can be figured out. Therefore we know now that the answer cannot be B, C or E. It will have to be either A or D. What I'm going to do now, before we get to second statement, in between part here, is something that we will never ever do in the real exam. It will be a sheer waste of time. But for learning purposes, let's find out what was the price in 1970. I'm curious. Let's do it on the top. Should we do it on the top or should we leave the top for the second statement? Let's continue here. So, erase this part here. And if you don't like this notation of P with subscript 70, p with subscript 70, you can very easily replace it with the traditional notation of x, if it makes you happy. If it makes you happy. So, if you subtract x from both sides, 3.5x minus x would be 2.5x equals 102.40. Multiply both sides by 100 so that we can get rid of the decimals, and you end up with x equals to 102 over 256. You see, it's just a matter of doing it out. It's not a big deal at all. It can be very easily done. It can be very easily done. Now, because this is a large number, 10,240, I don't want to deal with such a large number. I'm going to write this as separately. I'm going to write that as times 10 so that it's easier to deal with. Now, if we had to actually do it out manually, this is how we would do it. Obviously, they are both even numbers. They can be divided by 2, but if you divide it by 2, it will take a little bit longer. Let's see if we can divide both of them by 4. How do you know if a number is divisible by 4? A number is divisible by 4 if the last two digits of the numbers are divisible by 4. For example, if I give you 384, you don't have to worry about 300. You don't have to worry about 300. You only have to concentrate on the last two digits. As long as the last two digits are divisible by 4, the number itself is divisible by 4, because it doesn't matter what number do you have in 100 digit, any multiple of 100 is divisible by 4. If 100 is divisible by 4, then so is 200, and so is 300, and so is 700. Any multiple of 100 is divisible by 4. Similarly, you don't have to worry about the 1000 digit, because if 1000 is divisible by 4, then so is any multiple of 1000. You only have to look at the last two digits. Here I see 24, which is divisible by 4. Here I see 56, which we know is divisible by 4, because 56 is only 4 less than 60. And I know 60 is divisible by 4, because 15 times 4 15s will make 60. Let's divide top and bottom by 4, shall we? I'm going to do it here so that you have easier time seeing it. Let's divide this by 4. How many fours? How many fours in a 0? In a 1? 1 has no fours. 1 has 0 fours. That one goes and joins the 10. Joins the 0, becomes 10. How many fours in a 10? 10 has 2 fours. The remaining 2 goes and joins this guy, becomes 22. How many fours in a 22? 22 has 5 fours. The remaining 2 goes and joins this guy, becomes 24. How many fours in a 24? It has 6 fours. Oh, what do you know? It's exactly 256. Oh, that makes it easy. In other words, 1000. In other words, we just found that 1240 can be written as, let's do it here, can be written as 4 times the amount. This can be written as 4 times 256, and of course we have times 10. 256 drops out, though that was easy. So x is 40. The question was, what was the price of the mixture in 1970? Given the fact that by 1989, the same mixture was selling for 3.56 times the amount. Oh, there you go. The same mixture was selling for $102.40 more. The question is, the mixture was originally selling for $40. But like I said before, this is not something you will do in a real exam. Do you understand? Let's look at second statement. In the second statement, they tell us the price was, what the hell, isn't that the same thing they told us before? Oh, in the first statement they tell us it was $102.40 more. In the second statement, it's not $102.40, it's $142. It says price was $142.40 in 1989. Before we do any work, you should notice here that we just finished claiming that the price in 1970 was $40. And the problem tells us, in the first statement they told us that it was $102. It was $102.40 more. It was $102.40 more, and what we claimed is that it was $40. That was our claim. At the end we found out that the price in 1970 was $40. If the price in 1970 was $40, and the first statement told us that the price had gone up by $102.40, this must be the new price, 142.40. What do you know? That is exactly what it says here. That's just your peace of mind. Now we know that whatever work we did in the first statement was in fact correct. We can't use any information from the first statement to use in the second statement, obviously, but they always substantiate each other. That's your peace of mind. That's your insurance. If you found something in the first statement and immediately in the second statement they themselves tell you something different than what you found out, if you did all the work and you found out that Michael was 8 years old, and as soon as you get to your second statement they tell you Michael is 7-year-old, something is wrong. Because you claim that he was 8 years old, and they're telling you in the second statement that he's 7 years old. It doesn't work that way. They always substantiate each other, as you can see here. Anyway, let's do our work. So price was $142.40 in 1989. This is too straightforward. So price in 1989 equals 3.56 times the price in 1970. We know the price in 1989 is this much right here, 142.40. 3.56 times the price in 70. Of course we can solve for it. We just have to divide one by the other. Second statement by itself is also enough. Therefore the answer is D. Therefore the answer is D. Now, just for learning purposes, we can actually do it out, shall we? So here we have 142 times 100 will become 40 over 356. Essentially, we're multiplying both sides by 100. We're multiplying both sides by 100 so that we can get to the decimal place. 356 divided by 14,240 divided by 356. Again, I'm going to do the same trick. Keep this 0 separate so that we don't have to deal with a huge number. I see a 56 which we know is divisible by 4. I see 24 which we know is divisible by 4. 24 is divisible by 4. 56 is divisible by 4. Let's divide top and bottom by 4, shall we? How many 4s in 14? 14 has 3 4s. The remaining 2 goes and joins the 2 becomes 22. How many 4s in a 22? 22 has 5 4s. The remaining 2 goes and joins the 4 becomes 24. How many 4s in a 24? 24 has 6 4s. Oh, what the hell? Again 356. Well, that makes it easy. In other words, this guy here, this thing can be written as 4 times 356. It's 4 times 356. This 1424 could be written as 4 times 356, and 356 drops out, and again we end up with a price of 40, just like we did before, nothing different. Do you understand? So that was the end of that problem. Let me quickly take a look at this next problem because I think I've taken a little bit too long here. I'm not sure if I want to start a new one. Let me take a look at the next problem. Let's call it a day, okay? I'll see you tomorrow. Bye now.